All right, changes in matter with heat and changes in matter. All right, so let's talk about this. All right, so let's get into this. Okay, now we have vibrational kinetic energy, potential energy, rotational kinetic energy, translational kinetic energy. Energy of motion in a body, potential energy, energy possessed by an object as a result of its internal state or its position with respect to other objects. Heat transfer of a warmer object to a cooler object, so transfer of energy. We know that from the last one. Temperature, degree of hotness or coldness of a body or environment. So the measure of average kinetic energy of the particles here. So gas, as you can see, it's everywhere. Liquid takes the shape of whatever container or thing that it is in. Here, just gives you a couple questions and graphs. Ice experiment, if you tried that, like watch ice melt, it turns from a solid to a liquid. And here's kind of like what happens here, as you can see. So it increases energy as it's going. So increased kinetic energy, increased potential energy, increasing kinetic energy again, and then it increases potential energy, increases kinetic energy. So it's just showing you the cycle of how water is melting. Okay. Heat of fusion. Amount of heat a solid must absorb for 1 gram of it to transition into a liquid. Okay, so the graph just shows what is going on when it is transforming into a liquid. Here, solid to liquid, liquid to gas. Heat of vaporization, the amount of heat a liquid must absorb for 1 gram of it to transition into gas. So again, liquid into a gas. Specific heat, the amount of heat required to raise the temperature of 1 gram by a substance 1 degree Celsius and it's usually measured in joules. So you'll see joules per gram, joule/gram. You'll see that a lot measured in let's see. All right, so to evaporate from a liquid to a gas, water must gain potential energy. To change from a liquid water to solid ice, water must lose potential energy. Okay, so this just gives you a couple examples, equation. Couple equations solving the problem. You'll see joules a lot again. Significant figures, again, go back to that significant figure mini lesson I did. It'll explain it to you in a little bit more detail. Okay. Melting ice. Calculate heat of fusion. So this is what happens when melting ice. Rise in water temperature, what goes on, and then total heat absorbed, what is happening. Okay. Effects of evaporation. What happens when the sunlight would evaporate water. That's if you hang clothes out to dry, kind of what is going on. Okay. And again, simulation, gas properties. This is in the last tutorial. It shows what's going on. So energy level, we can click on this one, what happens. We turn the heat up, what goes on. Let's see, they're gonna move a little bit faster. Now they're moving pretty fast all over the place. Okay, so let's see. This just talks about, let's see, more particles moving. Evaporation versus equilibrium, what is happening again? Okay. And hopefully that just clears it up a little bit for you and kind of gives you a better understanding.